Good afternoon, all. In the last session, we have seen membership functions and its various features. So, in today's session, we'll see the fussification and membership value assignment. So, coming to the fussification, before we go for fussification, so this is a basic fuzzy logic system. So, let us assume that input is crisp input because we will give the crisp values, very clear values, and those values will be fed to the fuzzy system or fuzzy logic system, and output also will take it as a crisp input. So both input and output are crisp inputs. It means clear inputs, clear in definition. Okay, but in between we are sending that crisp values through that fuzzy logic system. So in this process, in the starting of that fuzzy logic system, the crisp inputs will be converted to the fuzzy values. So that process is called the fussification. Fussification means converting the crisp values to the fuzzy values. Fuzzy values means there is no clear definition to that values. So again, in the fuzzy logic system, while you are getting that crisp output, that fuzzy values need to be converted to the crisp values at the output. That process is called the defussification. So here fussification, defussification. So we are giving the crisp input, crisp output. That is nothing but yes or no, or the crisp inputs, or crisp input means clear inputs. So tall or stronger. So there is no uncertainty. We are not entertaining the uncertainty in the values. So there is a clear inference from the data. We can get the clear inference from the data. So from the crisp input we can get it. That means from the crisp values we can get it. But from the fuzzy values we do not get it. For example, if you take one example like taller, shorter, tall and short, if you want to decide those things means, so the people who are having height above 5 feet means tall, I can say like that. But few people may say that above 5.6 is considered as height. For 5.6 means that may be 5.8, that may be 6, that may be 7. So which I need to consider it as tall. Or if it is short means below 5 means whether it is 4 or whether it is 3. So there should be some range, right? So that range you'll get it in the fuzzy system. But out of that range you need to get one output. So that the rule based system will be designed in the fuzzy logic system. That rules will be given by the user only. So for example, for the same example, if height is between the 5.5 to 6 means he is tall. If it is 6 to 7 means taller, and from 5 to 5 point means medium height. Below 5 means, that means 4 to 5 means that is shorter. Likewise, we can give some rules. Those rules will be given in the fuzzy logic system. So by understanding the rules, it will give some output. If you provide the crisp input means clear input means your height, you can give it as an input. That height is, let us take that height as some 5.3 as a height. If I provide as a crisp input to the fuzzy logic system, that 5.3 is converted into the, through the fussification, it will convert to the fuzzy value, and that fuzzy value based on the defussification or by going through that rule based system. A rule based system means as earlier we were decided from 5 to 5, 5.5, 5.5 to 6, 6 to 7. So those we were given some height indicators. So as we were given 5.3 as a height, that 5.3 comes under medium height means. So that medium height will come as a crisp output. So in this process, the rules are very important if you are providing more number of rules. So here I have taken every 0.5 difference or 1 difference. If you want to provide more rules, you can take 0.2 as a difference, 5 to 5.2, 5.2 to 5.4, 5.4 to 5.6, some other height indicators. Like that you can provide. And from that only you will get the output. By understanding the rules, it will give the output. So defussification also, we have few rules in the defussification that we'll see in further session. So first we'll see the fussification. So this is basic fuzzy logic system. Fuzzy logic system will work based on the fussification, a rule based system, and defussification. So we'll provide the crisp input and we'll get the crisp output only. For 5.3 height, what is the height indicator? That will get it. Okay, by understanding that rules, what we are given to the fuzzy logic system. So first we'll see the fussification. So fussification means it is the process of converting a crisp value into the fuzzy value. I hope all of you understand that crisp value and fuzzy value. Fuzzy value will have a range. Okay, crisp value means one clear value. So by the converting the crisp value into the fuzzy value is nothing but fussification. By identifying some of the uncertainties, that uncertainties means, that's what I have told, uncertainties in the crisp values, the fuzzy values were defined. By identifying some of the uncertainties means, let us take another example like grading system in the academics. The people who got grade between the 9 to 10 will get the S grade. So that is fuzzy. 9 to 10 means between 9 to 10 they may get 9.1, 9.2, 9.5 or 9.9 also, right? So based on our rules, we can include either 10 or we can exclude the 10 or we can include the 9 or we can exclude the 9. Likewise, greater than or equal to or only greater than. Likewise. So but between 9 to 10 means, for example, if one person got 9.5 means that is a crisp value. For 9.5, what grading I should give? Or do I have to call him as a S grade student? Then what about 9.3 student? Or what about 9.8 student? So instead of that, I can give some range and I can give some rule. So by understanding that rule and by sending the crisp value like 9.3, but I will give it as an input to the fuzzy logic system, then I'll get the grade. That grade may be based from 9 to 10. S grade means S grade I'll get it. If it is between 8 to 9 means that is A grade means, or 8.5 to 9 A grade means between that 8.5 to 9 how many grades will get it, that will be assigned with the A grade. So that 8.5 to 9, 8.5 to 9.0 is nothing but fuzzy range. So those uncertainties are there in the crisp values, right? So those were defined with the fuzzy values, with the rules. The conversion of fuzzy values are represented by the membership functions. The conversion of fuzzy values means again the same, the ranges are represented with the different membership functions. So that may be A grade, B grade, S grade, D grade. Likewise, we will decide few rules and membership functions. So the fussification involves assigning the membership values for the given crisp quantities. The fussification means you have to convert the crisp values to the fuzzy values, right? So by using the rule based system, the crisp values are assigned with some membership values. So here fuzzy membership value will vary between the 0 to 1, right? If it is 0 to 1 means between the 0 to 1. If it is 1 means let us understand the same example like 9 to 10 is S grade means if it is equal to 10 means complete membership value will get it. That is nothing but 1 you will get it. If it is 9 means you will get the 0 in that particular range. Membership value is 0. If it is 0.5 means you will get a 9.5 as a membership value. Sorry, yeah, for 0.5 membership value your grading is 9.5. Likewise, we will give or we will assign the membership values for the given crisp quantities. Okay, so the membership value assignment is of will have very different methods are there based on intuition method, based on the inference method, based on the rank ordering method, even few other methods also there like angular fuzzy sets. See here you can represent in angular fashion also, that means in degrees also. Instead of taking 0 to 1 in Cartesian system, you can go for angular fuzzy sets also. Neural networks, genetic algorithm, even induction reasoning, all few other methods also there based on the application. So the membership values will be assigned. So the basic membership values are intuition method, inference method, and rank ordering method. We'll see one by one. So intuition method. The intuition method is based on the human's own intelligence and understanding to develop the membership functions. That means like I was given 9 to 10 as a S grade means few people may give 9.5 to 10 as a S grade. So 8.5 to 9.5 as a grade. The grading system will be different from one university to or one academic institution to other academic institution, right? So that completely based on the human's own intelligence and the membership values or functions will be decided. The complete knowledge on the problem need to be known or has to be known. That means so complete problem or complete knowledge means complete knowledge need to know means you should understand. We cannot give 6 to 7 as S grade means S grade, right? So then 7 to 10 what do you give? S grade is highest grade means, and that range also we need to fix it properly, right? One a grade difference or 2 grade difference or 0.5 grade difference comes under one category. So we should have complete knowledge, then only we can frame the rules. Those rules will be given to the fuzzy logic system. The knowledge regarding the linguistic variable should also be known. That's what I've told. The knowledge regarding the linguistic variables means whether it is S, A, B, C, D or taller, shorter, medium height. So those are variables need to be define it properly. When we understand it when we understand that knowledge or when we understand about that issue properly, then only we can give that variables properly. We cannot give that 9 to 10 as if F grade, right? You cannot come in a reverse manner, right? Everybody should understand very clearly whatever we have given. So taller means it is not 3 to 5, 3 meters to or 3 feet to 5 feet height is not taller, right? And then 5 feet to 7 feet is shorter, like that I cannot give. So we should have complete knowledge, we should understand the variable, we should know the linguistic variables. So all these based on the human's own intelligence. This intuition method is generally will follow this intuition method only. Intuition method is completely based on the human's own intelligence. If we take one example for the intuition method, first example is membership functions are representing the imprecision in crisp temperature reading. Let us see that membership function mu, membership value is assigned with from 0 to 1 on the x-axis temperature. When you measure the temperature, the dotted line shows that the reading noted. So that is a accurate reading. So for the dotted line, the corresponding membership value is assigned with 1. That is accurate reading. Corresponding to that accurate reading, the membership value is 1. If it is less than that reading noted or noted reading, then it is deviating from the accurate reading, right? If it is less than or greater than. So for that we need to give some tolerance, or we need to give some different value. So that I here I was provided, like if it is the reading is less than the noted reading, then there is a 0.5 maximum of 0.5 percentage of deviation, and if it is greater than also, there is a maximum of plus 0.5 percentage change in the temperature. For example, the noted reading is, let us take the 10 value, or 20 degrees centigrade is the temperature accurate temperature reading. So if it is 18 means, correspondingly 18 will have some other membership value. So corresponding to that, you will get the deviation in the temperature, that may be 0.4 percentage. If it is 15 means, that may be 0.3 percentage. So likewise, if it is more than that means 25 means, it may be 0.3 or 0.4 percentage of change in temperature with plus value. So here that range need to be decided with the knowledge and the complete setup or complete experimental readings, or whatever the data we have. So here 0 to 1 membership value is assigned for the change in temperature from minus 0.5 to 0. In a similar way, from 0 to plus 0.5 also. So 0 to 1 membership value on the vertical axis, membership value, right? The membership value is equal to 1 when we noted the correct reading. If it is less than means, that will vary, that membership value will vary when the temperature is varying from 0 to minus 0.5 percentage, then membership value will change from 1 to 0. In a similar way, when a membership value is changing from the accurate reading, let us take accurate reading as x plus 0.5 percentage of x reading, till that value your membership value will change from 1 to 0. Likewise, if you take another example, the membership for fuzzy variable speed in RPM. Let us take the same example, like wind turbine speed. If on the x-axis, that is speed axis, y-axis is membership function, the maximum membership function is 1. 0 to 1 membership value will change. So your wind turbine speed may be high, may be medium or low. So correspondingly here I have given 3 membership functions. One is low membership function, medium membership function, and high membership function. If it is low means between 0 to 1000 RPM, that I'll consider as low speed. So that low speed is based on our intuition or inference. So I have treated as low speed means from 0 to 1000 RPM means that is low speed. That membership function I was given. So when the speed is below, let us take below 400 RPM, the membership need to be assigned with 1, completely low. So that means it is low mean. Again, medium membership means it is 500 to 2000, and high speed means 15, greater than 1500 RPM is high, high speed. So if you see very clearly here, the low and medium membership functions are intersecting with each other, as well as medium and high speed membership functions also intersecting with one another. That means if you consider a speed between the 500 and 1000, which is nothing but, let us take some 700 rpm, that 700 rpm will comes under low membership as well as the medium function, also medium fuzzy function. So that means we are entertaining the uncertainties between the speeds. 700 rpm, it comes under the low speed range as well as the medium speed range also. Because less than 1000, that is low speed, between 500 to 500 to 2000 also medium speed range, right, what we were giving. So that need to be solved by the rule based system by providing it to the fuzzy logic system. You can provide more a rule based system to get the more clarity on the speed ranges. So now whether we need to consider that low or medium or some other parameter, you need to decide fuzzy function can be given to that 700 rpm, that will be decided by the user itself. So the next method is inference method. So this method involves the knowledge to perform the deductive reasoning. Deductive reasoning means one depends on the other. So one parameter will depends on the other parameter depends on the some other parameter likewise. The membership function is formed from the facts known, that means known facts and the knowledge. So if we take an example, then you'll understand better. Let us take an example. Let's consider U as a units of triangles, and A comma B comma C are the inner angles of the triangles. Triangle means there are three inner angles, right? Those angles are A comma B comma C. To form a triangle, your A should be greater than or equal to, B should be greater than or equal to, C should be greater than or equal to 0 degrees, right? If any angle equal to 0 means there will not be any triangle formation. So that's why A is greater than or equal to, B is greater than or equal to, C is greater than or equal to 0. Therefore, the universe is given by units of discourse is nothing but A comma B comma C, such that the rule is, or the condition is, A is greater than or equal to, B is greater than or equal to, C is greater than or equal to 0, and also to form a triangle, your summation of all the angles A plus B plus C should be equal to 180 degrees, right? So this is a condition. So let us assume there are three types of triangles. Here I have given as a condition. One is, I am considering I is the appropriate isosceles triangles, and R is the appropriate right angle triangle, and O is the other triangle. Simply here three conditions or three rules I were framed. Now the membership values for isosceles triangles, the mu I of A comma B comma C, that is nothing but the membership function should follow the 1 minus 60 degrees 1 minus 1 by 60 degree of minimum of A minus B comma B minus C. Minimum means that is intersection of A minus B comma B minus C. So then it will form the isosceles triangles. So here I am not explaining that in detail into the mathematics, but let us assume that minimum of 60 degrees, so 1 by 60 of minimum of A minus B means A minus B comma B minus C means minimum of means it need to go for intersection of A minus B and B minus C. If you want to get the right angle triangle means mu or A comma B comma C is equal to 1 minus 1 by 90 of minimum of A minus 90. Okay. So by that right angle triangle, the other triangle is nothing but which are not comes under isosceles triangles, and right angle triangle is nothing but other triangle, right? So to get that other triangle, let us take I isosceles triangles plus a right angle triangle, that is nothing but I union R, right? The complement of I union R is nothing but other triangle. Simply that is represented with mu O of A comma B comma C, that is other triangle, is equal I union R complement, or I union R whole bar. The same thing you can rewrite as per the De Morgan's law. Mu O of A comma B comma C is equal I bar intersection R bar. I bar intersection R bar is nothing but minimum of intersection, right? Union means maximum, you will get it. Maximum of the components, you will take it. Intersection means minimum of, right? So minimum of I bar means 1 minus mu I of A comma B comma C, comma R bar means 1 minus of R complement means 1 minus R, right? That's what I have written here. 1 minus mu R of A comma B comma C. So based on this we were solved already numericals in the previous sessions. So these are the membership, like this will assign the membership values to get the three different type of triangles what we were designed the rules. The next method is rank ordering method. Here let us understand that rank ordering method is nothing but the polling concept. If you want to give some rank means you need to have some data based on the number of polls, first, second, third, like that we can decide, right? The polling concept is used to assign the membership value by rank ordering process. So here preferences are above for pairwise comparisons, and from this the ordering of the membership is done. So simply pairwise comparison means one need to be compared with the other to give the rank. So that we'll see with example. For example, let us take 10,000 people. A survey has been conducted on 10,000 people. So 10,000 people were responded for a questionnaire about the pairwise performance among the 5 cars. Okay. So in that define a fuzzy set as A on the universe of cars, best cars. So this table shows that the pairwise preferences among the 5 cars between the 10,000 people, that is. So the number who preferred are the cars models were considered here: Palio, Sina, Astra, Easter, Baleno. The Palio and Sina, Astra, Easter, Baleno all are considered based on the preferences given by the 10,000 people or responses of the 10,000 people. If you take the out of total 10,000 people, so let us take that around the paleo is considered by the 515 people over the Sina, Astra 545 and Easter 523 and Baleno 671. So likewise Baleno is considered over the paleo around 265, the last but one line row, and 425 people preferred over the Sina, and 402 people preferred Baleno over the Astra, and Easter over the Easter Baleno were preferred 389 likewise. So if you do the summation, the paleo was preferred over other models, other 4 models. The total number is 2254. Likewise Astra, Easter, Baleno also, Baleno is preferred over the other car models. Around 1481 people were preferred. If you do the summation, total 10,000 people are there. The corresponding percentages are 22.5%, 23.8%, 17.7%, 21.1 percentage, 14.8 percentage. Based on this percentage or based on the total number, if you give the rank, so first place will go to the sign, and second is paleo, third one is Easter, fourth one is Astra, Baleno is fifth place. So Baleno is preferred over the other models only 14.8 percentage. That means fifth rank means only 14.8 percentage are preferred Baleno over the other four models. So like this we can give the membership functions or rank or membership values. So if we take the same thing as a membership functions, on the x-axis you can take the car models, y-axis membership function, the maximum membership function is 1. So car models were represented on the x-axis. So the same thing were given with the bar chart. So likewise, for one particular model, what membership value will be assigned? If it is 25% means what? If it is 30% means what membership value we need to given. So these things will be decided. And membership for best car is, let us take the membership for best car is 1. The complete membership value given to the highest opted car, that is sign. The least is Baleno, that will be correspondingly that the membership value will be decreased. Okay, so this is all about the fuzzy logic system and fussification and various methods. Thank you all.